although this exercise is named the notation for the derivative, there's a far more important aspect to this exercise than just being introduced to the notation, which I've been trying to do anyway through the other exercises. And that is that they're now starting to present you with some functions that are not in a format that immediately we can differentiate. So we're going to have to do some rearranging. We're going to have to get x's out of the denominator. We're going to have to remove square root signs. And just in general, always be aware that if for some reason you know that you could simplify the function given to differentiate, for example, if you were given that f of x, just for some reason they'd written it as 2x plus 5 minus x, we wouldn't differentiate this in this format. We would rewrite this as 2x minus x is x plus 5, and then we would differentiate. So, a little piece of advice is simplify always if possible. Now that's especially when differentiating. It's almost what we do anyway. We simplify just to make the process easier. And just summarising what we've done so far, the process for finding an expression for the gradient is, at a curve on a point, at a point on a curve, is called differentiation. To actually calculate the value of the gradient, now they're two different things. You can get an expression for the gradient, or you can be asked to calculate the gradient, find the value of the gradient. If that is the case, then you need to know where you're at, what the x value is, and you substitute that into your gradient expression. You've seen this notation, f dash x. You've heard me say dy dx. d dx of y is also acceptable, and y dash. So they're your different ways of writing the derivative expression. And you might be wondering which one of these to use. It usually depends on the form in which the function is written. So if the function is given as y is equal to x cubed minus 5x, and we want to differentiate it, we've got some options. We could choose y dash, or we could choose dy dx. We probably wouldn't use f of x, only because the function wasn't named as f of x. It was named as y. Now, that takes me on to something else. There's nothing special about y and x. You can't, it doesn't mean that you can only differentiate if you've got y and if your variable is x. No, that's not the case. You can see here, you've got an expression, v is equal to u cubed plus 4u. There's no reason why we can't differentiate that function. It's a function named v where the variable is u. We'd be able to bring the power to the front, subtract 1 from the power and get an expression in terms of u. We would be able to differentiate with respect to u. And the way we could write that is we're going to differentiate the function named v with respect to u, du. The function you might be given as h, name it h, and the variable you're using is g. And again, there's no reason why I can't differentiate this function with respect to g. I bring the 2 to the front, subtract 1 from the power, minus 4. The way we would write the notation for the differential would be, we could have, dH dg or d dg of h. Now, at the risk of confusing you, but I don't think I will confuse you, I will talk about why we don't call this h dash, why we didn't call this one v dash. It's because, but we can call this one y dash. The rule or the understanding is that you will only use that very abbreviated form, in fact, when the function is named y and the variable is x. You're going to see a common variable used is t. When we get to applications, it could be something like that. Y in terms of t. And in this case, it is incorrect to talk about y dash also, because this y dash is specifically for when a function is named y and the variable is x. Yeah, I don't think you'll be confused by that. Okay. Yes, I should stop the video there and I'll do these examples and talk about them in another one.